All right, let's take a look at this. Oops. Oh, God. Problem sign. What is this one on? This is. Let's do that one first. All right. Hey, hey. Can you hear me? Hello? For some reason, everyone always. I think you're muted.
Hi.
What's been good?
I'm sorry?
What's been good?
Oh, nothing much.
Okay. How
I
was your
this.
this thing? Like I was looking at your problem 7, and then what was this, the PV diagrams? Did you end up getting these?
The PV diagrams?
Yeah.
Oh yeah. She didn't really go over diagrams. She went over diagrams in problem 8. the isothermal curve, but she didn't even
Okay.
explain
Yeah,
it.
like the way she writes, is this her writing? Like the I'm looking at like the images that you sent me.
Yeah, it is her writing. The screenshots?
Yeah.
Yeah, that's her.
Yeah, it's a little confusing the way she's not really explaining, like, there's a lot of assumptions in a way. Or maybe
Yeah.
she was like rushing. But like, yeah, it's pretty normal for professors to really, not explain every single step, and because they really leave it up to you to like go back and it's like, oh, okay, I figured it out. But
Yeah.
so maybe we can. Do you want to talk about that first?
Yeah, we can go over the screenshots. Let me just go back to them because I haven't looked at them since I sent
Okay.
them. 1 second.
And I'll do my best to write it.
Okay.
A lot of students really like it when it's like, oh, can you please like write it step by step? Yeah, sometimes like, yeah, there's more preparations for that, but we'll make it work.
Okay. Hold on. Let me find
Okay.
one. Problem 8.
Anyway, is your exam already tomorrow?
Yeah, it is tomorrow.
Oh man, it's every 2 weeks, isn't it? Or
Yeah, like every 2 weeks or something like that.
okay.
Like 2.5 weeks.
Are you ready?
Not really. And
Okay.
this time she's making it in person, like a douchebag.
Oh, this time it's in person. Last time it wasn't.
Right.
And that means you can't cheat. No, I'm just
Nope.
kidding.
Nope, sure can't.
Yeah. Well, this one isn't that bad, right? Like, as I remember, you said you
Yeah,
got.
this isn't, yeah, it's not nearly as bad as Bernoulli's or anything. So,
Yeah.
but I was practicing a few problems and I was getting it. So that's
You
good.
were getting it.
Yeah, it was.
Okay. That's relief.
But you know
Yeah.
how the process always changes depending on the problem. Like there's always something different. So,
Which problems did you do? Like, is that like book problems or the ones that
yeah, I
she
did word problems. Yeah, I did the temperature at a rigid, constant volume. I forgot which one this was, but it's one of the problems.
Okay. Let's just go over this one first, because
Yeah, let's go over this one. Hold on, let me write it down.
Okay. So I'll talk while I'm writing. So you know how you have the picture in front of you, so I'm not gonna technically redraw it,
Right.
but this PV, pressure, volume. Did your professor talk about these things? Like technically, like depending on your picture of your PV diagram, the way it's formed, this guy, like you're gonna get like three different sets or three different like types of graphs, and then this right here really will show you, like, or you can in a sense, like depending on the graph, like each point, obviously I'm just gonna draw this guy that's on problem 7, where you have this, right? This is what you have, something like that.
Wait, hold on 1 second.
Okay.
I did I do this one? Hold
You
on.
do this one.
I'm trying to see.
Okay.
Oh, I did do problem 7 and I got it.
You got
Right.
this on.
Yeah, I just don't really get like what she was trying to say with the curve,
What curve?
the thermal curve, but I don't know if this is a different problem. I think it is.
Okay.
Did
Thermal
you
curve.
see the screenshot with the thermal curve?
I got the problem 7 one. Is this the second one? Second screenshot?
Yeah. Well, I sent you 3 of them.
Yeah. Is the thermal curve the second one or the third one?
It's that red and red ink.
Oh, so it's the second one, right?
Yeah.
Okay. Anyways, like all of this is pretty much the same. Like when she's saying thermal curve, it's just this guy, PV. Like, it's a thermal curve. Did you guys touch on thermodynamics yet? Or is it just still PV?
Yeah.
And our
Well, you touched on isothermal, but that's it.
isothermal. Okay.
Yeah.
So you did touch on it.
Yeah.
What are these other ones? Have you heard of isobaric and
Yes.
isochord?
Yeah, she went
Okay.
over all of them. Yeah.
Okay.
Baric is pressure constant.
Yes.
Metric is volume constant, and thermal's temperature constant.
And technically there's a fourth one, but no one
Yeah,
ever talks about it.
yeah, she didn't really give problems on that though.
Yeah, this one is like not well. It's kind of like this guy. It's kind of like this guy, isothermal, but it's steeper. That's what I see it as.
Hmm.
Anyways, like, okay, let's talk about that isothermal curve. So, like you have this guy, right?
Hmm.
And then I can't really like. I'm guessing she wrote this really fast, but doesn't matter. We have this guy that's 1, I think, and then I guess there's a 2 here. This is 2, but like she just has it as final.
Yeah.
But these are the states. This is just arbitrary. I'm not gonna like base it off that. But I'll explain it afterwards. But you know how like you have these different states: first state, second state, third state,
I guess.
and then like depending on like you can pick out the different V's, the different P's, depending on the coordinates of these guys. And so like if you take a look at this first one, 1 to 2, what is this? This is ISO 1.
Thermal.
Yes, yeah. Good, yeah, you actually get this one. Like a
Well,
lot of
she
people.
said that, but I don't know why. And I asked her, and she was like, "Well, this is in your notes."
I
And
see, I
I was
see.
like, "Okay,
This
fuck you
is this the
then."
question? Is this the question?
Yeah. I was like, "All
Okay.
right, fuck you, bitch.
I
Whatever."
mean, it seems like was like did you ask her in class like during the session or was it like a private?
Okay, literally all she said, I was like, she's like, "So this curve is isothermal," and I asked her, I was like, "Well, what makes it isothermal?" And then she just wrote, "Well, because P equals the constant over V, and that's always a parabola."
I see. That's
But
her
this is
answer.
all in your notes, and
Yeah.
that's all she said.
Okay. So let me just define it. Yeah, it's usually like that. I would just say like maybe she shouldn't have told you look at your notes. Or maybe just like end it there. But they're usually like that. But one thing I would say is, if you take a look at this curve, you know how like you have iso, just to define these. So you know how you have isobaric, right? Isobaric PV is this guy. It's straight, horizontal, right?
Mm-hmm.
And then the other guy, these are very important because this is how you tell that what is what in here, what you
Yeah,
can assume. Isochoric is what? This guy, right?
that's
It's straight
volume.
up. Yeah, volume choric, yeah.
Oh, I
Good. You
see.
did, you did
I know it as metric, isometric.
isometric? Is that what you said?
Yeah.
Oh, that's weird. Isometric is something else.
Sorry.
Whatever. Okay. Isometric. It's like that's like a drawing thing. Okay. Anyways, PV. The other guy is this last one, isothermal.
Uh-huh.
It's this. It's a parabola. She's not wrong, but it's like the way it's like this guy is the same form as this guy, right? It's a parabola.
Mm-hmm. Okay.
So that's when you know that T1 equals T2.
Okay.
She says that somewhere, and that's how you can get like the final, the T3, because T1 equals T2, and then there's a relationship between T2 and T3. It's like connecting the dots, like pretty much in all of these is like, okay, what can you see? Like what is given to you? Given to you means like what can you read from your graph and like axes, and then the ones that are like harder to get is okay. What is this isothermal? Is this isobaric, isometric? And then so this guy, what is this guy? The 2 to 3.
2 to 3. Isobaric.
Yeah,
Compressible.
isobaric. Yeah, it's a like so that right there is not hard, right? Like you can just like this guy to this guy. What does that mean if it's isobaric?
Constant pressure. So
Yeah,
P1 equals. Oh, well, what about P1?
but P1 you could read it, right? You could read it from here, right?
Oh, okay. Yeah.
Yeah. So it's a combination between those two. Like, what do you have? And then obviously the third thing you have the axes, you have the graph itself, and then you also have what? You also have this PV equals nRT, right?
Yeah.
Yeah. And then this can be like, whatever state you're in. And then you can relate it. And then depending on like what is constant or like what's equivalent, you can just relate, like, have this as like one side being this guy equals maybe 1, and then the other side would be 2. it's just messing with all, you know. And in this PV diagram, that's why she's calling it thermodynamic curve. Is did you guys touch on the first law yet?
The first law? No.
Yeah. The next thing would be like maybe, I don't know if you guys, I did look at the other chapters, but as I remember, it's like you guys will touch on it. First law, second law, you know. Anyways, like the reason why it's thermodynamic curve is this PV relates it back to like the first law. So like by reading off the PV, like everything about this PV diagrams will tell you about the first law of thermodynamics. So that's why it's a thermodynamic curve.
Okay, hold on. I'm just writing down the graphs.
Okay. Here, let me see if I can. There's actually this really good website that has like all the things I was talking about.
Okay.
I'll just send that to you.
Okay.
Yeah, it's like physics.info. It defines like all of that. It may be too advanced, but it's always good to be like, you know, if she's gonna ask you a question, at least you can answer.
Okay, hold on. So 7 I was able to do. I did that one.
Okay.
So this is, I think, problem 8. Yeah. So okay, this like red graph thing is for problem 8.
It's for problem 8, yeah. Problem 7, we can cover that one, but you said you got that one.
Yeah,
already,
I
right?
understand problem 7. Yeah, I got that for sure. I practiced that one today and did it.
Yeah. Okay, that's good. It's really just a one-stepper, right?
Yeah, it's pretty
Yeah.
easy. It's just like manipulating the equation.
Okay, so like for problem 8, or is this problem 8 the red graph?
But let me pull it up so
Okay.
let's see.
So just to talk about it, so what she has there, like at the bottom, you know, this like bottom equation, I'll just write this one. It says like 2 times 101 300, and she had like V1 right here, and then P2 2V1.
I think it's problem 8.
Is it problem 8?
Says a gas at 2 atm. Oh yeah. And a
Okay.
pressure of 200 degrees Celsius is first expanded isothermally. Yeah.
Also, it does tell you it's isothermal. Okay. It does tell you
Yeah.
it's isothermal. Okay. At least that's given. Sometimes they want you to read it off from the graph. But anyways,
Yeah.
like,
You want me to share my screen or?
yeah, like, do you understand, like, I guess, first of all, do you understand this though?
What you just explained? Yeah.
Okay. Yeah, because that's really the basics of it. Like those 3 things where, okay, any of those can be assumed, 1, 2, 3. And then like, like all the problems that she could give you can be this. This is just an expansion of like the ideal gas law. Okay, you can share your screen.
Okay.
Do you guys have the solutions for like, you know, I remember she always puts solutions on her slides.
Yes. It has a solution.
Okay.
But I thought this was the solutions one. Hold on.
Okay.
Wait. Today's solutions. Maybe it's this one. Pretty sure.
Nice.
Problem. Only up to 4. What about 8?
Oh, that sucks.
See why I hate her?
Did she give you guys like a review?
That was our review. It was just like
4 problems.
Problems, yeah.
Yeah. Okay.
All right. Well, she only has up to 4.
We'll take a look at those ones. Okay.
So let's go to 8, and then there's like this thing.
Okay, so that's exactly what she drew.
Yeah.
Like so you have this guy, right? T1 to T2. So like, first of all, let me ask you, what do you see here? You know, it's like a feedback loop. Like, what do you see?
I see that as the volume increases, the pressure decreases. When
Okay, good.
isothermally it expands.
Yeah, and that is the isothermal like process. And then now from 2 to 3, what's happening?
Volume is changing. It's getting smaller, but the pressure is the same.
Yeah. Good. If you can explain it that way, that's like very much like on spot. And then like now applying it. If you have like this P1, and then, like what is the question here? What is T3? Is that the question?
Um,
I think that's the question.
okay, it says, yeah, this.
Find the final pressure, temperature, which is T3, and the final pressure, P3. Okay. In your mind, like just you've already done a lot of these ones, but like, so you explained to me the process, the thermodynamic process. Then now, what is given to you? You're given what? This ATM.
Given pressure initial, which is 2 atm.
Okay, that's good. And then what's this other one?
Temperature initial, which is 200 degrees Celsius, which is 474 Kelvin.
Oh, so this problem, think about this problem. That graph was drawn because it wasn't given to you. Yeah, you would have to draw it, right? Or not? Is it given to you?
Probably not.
Yeah, because like, I'm thinking about this. Like, what if it's not given to you? But let me just read this. It says, first expanded isothermal until its volume has doubled. No, it's not given to you. Yeah, you have to like draw it from the words.
Yeah.
Oh man.
Annoying.
So like, yeah, you definitely have to practice this one. It's so like when you have this two, and then there's initial two, like I guess like pressure and temperature, P1, T1. I would just put that as a dot, like a coordinate, right? That's how you would draw it first. And then you read this thing, this next phrase is first expanded isothermally until its volume has doubled. So you can get from that like volume doubled. So and it's isothermal. So you do like a arbitrary.
That's where the parabola comes from.
Yeah, you just arbitrarily draw that, and then and when you see this thing, the 2 atm, you don't know the volume of that guy, right?
No.
So that's why you just put it as V1, like arbitrarily V1.
Okay.
And then, but when you're given like a process, isothermal, baric, or like isobaric or metric, whatever,
yeah,
you always have 2 points, right? You always have 2 points. So the initial point at 2, you're given the pressure, and then you drop down, you get V1, right? And then, but then that's the initial point. And then, so while you're drawing this, you have V1. It says here its volume is doubled. So at that second point of your isothermal curve, you have a second point, right?
So V2 is 2V1?
Exactly, yeah. So you have V1, 2V1, which is V2. I would probably just like, you start it out like that, and you have 2 in your pressure axes. And then, so you have that guy. Now let's read on. It then undergoes an isobaric compression until it returns to its original volume. So what do you do with this one?
Then goes isobaric compression. So pressure isobaric. So that means constant pressure compression?
Yeah, the compression part, it doesn't really matter, but like the isobaric is definitely the word.
Isobaric. Yeah, okay. See, that throws me off. Why did she throw in compression?
Actually, hold on. Let me step back. I spoke too fast. The compression, you know how like the other one is expansion, right? First expand isothermally, right? Just to go back. So first expanded isothermally. You should have
said it undergoes compression isobarically.
Yeah, good, isobarically. No, but what I'm saying is that there's 2 things in these things, in the way they're phrasing these. If you look at the first one carefully, it says expanded isothermally, right? And then the second one is isobaric compression. So this expanded means it's like left to right, and then compression is from right to left.
Oh, I see.
You can see it now, yeah. That's the other one, yeah. Because if it said expanded isobarically, then it's gonna go to V3, which is gonna be somewhere else on the right, not on the left.
Okay.
Yeah. So that's how you read it, from the words. That's how you draw your graph.
Yeah, I wish you would explain that. She doesn't really explain the connect with like, the word in the graph. That's like really, really crucial.
Does anyone like prompt anything like, hey, by the way, can you?
No one says anything in the class. Everyone's afraid to ask anything.
There's like 9 people I see in the class. Is that right?
Yeah.
It's so little. What kind of class is that?
'Cause a lot of people don't like this subject.
Okay, I see. Well, I would just say like, yeah, it's not, because like, you know, sometimes when you get on your bad side, like, like that's why I always gauge like whether a professor likes questions or not. You know what I mean?
Mhm.
Because like when you want to be always on their good side due to the grade, you know.
Yeah.
So yeah, just ask me all these other questions because like definitely, yeah, this is how we hash it out. Like, oh, okay, this is how you really key into the points of the problem and then draw. But does that make sense though? The
Yeah,
keyword.
like I
Yeah.
understand the words in the graph now, how they connect.
Okay.
So how do we?
Okay. The other thing as well is this other part. It says until it returns to its original volume, right? It says
That's
that. So you do have isobaric compression, so you know it's a straight horizontal line. You have compression, so it's going from right to left. The other thing is until it returns to its original volume. So you're given, you know that this is always like there's always a connection. So 2 here is the first point of your isobaric curve is the second point of your isothermal curve. So you know that because it's a connection. You can't just jump states, you know.
So
The one
P3
thing,
is the same as P1.
which one? Say it again.
So you're saying P3 is the same as P1.
Uh, no. P3 can't. It's not the same as P1. It's P2. P2 is
Oh, the same as P3.
P3. Yeah.
Oh,
And
okay.
the reason for that is because it's isobaric.
Right. Oh, okay, yeah. So P. Okay.
But what I mean is like this other thing that says returns to its original volume. Like the third point. It's the third point. But the second point of your isobaric curve, it has to land on V1, right?
Um.
Because it has to return its original volume, right?
Right.
It has to land on V1. So like I said, it's like connecting the dots, you know? Like you have to just, from the words, you have to connect where the dot like falls into place. And then if you get the graph wrong, you're definitely gonna, you know, that's like the most crucial part, right? Before you answer the question. So
Yeah.
like maybe is there another problem like this or is this the only one besides like P7, I guess?
There probably is more.
Okay. Anyway, like for this one, it's like, do you get that process though? Like you just pretty much lay out the keywords and then
Yeah.
like the keywords are really simple. Those 3 things, isothermal, baric, and choric, expansion or compression. And you know, what other information they give you in terms of volume or pressure. That's like the main things to like key in. It's like, oh, okay, those are the ones I'm gonna like remember, and then I know how to draw the graph from that. Once you have the graph, you just apply ideal gas law, right?
Yeah, but do I use it twice since there's 3 of each now, or what?
Okay. Now let's move on to that one. So you
Yeah.
understand you understand the graph, right? Like drawing the PV.
Drawing PV?
Yeah, like from words, like drawing PV from word.
I
From what
mean,
we,
in this case, in this scenario, yes. But if I see it worded differently, probably not.
that's what I said. You have to change like, you know, the wording. Like
Mm-hmm.
how let me think. You know how like you have 3 things, right? Like isochoric, isobaric, isothermal.
Yeah.
Just like combine those things. Like imagine like, or you know, thought process. Just like think about different ways that can be combined. Because this one you're combining isothermal and isobaric. If you see another problem, it can't be anything else, right?
Mm-hmm.
It's only one of those 3 that they can combine.
Mm-hmm.
And then yeah, like it's really just doing that. Like you have your ammo 3 things, and then they can ask you many things.
So
That's with
wait, let me just clarify. So with all the values.
okay.
So T1 is equal to T2
Why?
because it
What?
says that it expands isothermally.
Good. Okay. Good.
Okay, so
Continue.
T1
Yeah.
equals T2, right?
Yeah.
I'm
All
just trying
right.
to figure out all the values that I know. And then
Yeah.
so P2 and P3 are the same
Why?
because it compresses isobarically, right?
Good. Okay. Yeah. So
Okay.
that's what you have. Yeah. And what else?
And V1 and V3 are equal.
V1 and V3 are equal. Yeah.
Right? That's right.
Yeah, because it returns to its what? Original volume, yeah.
Mm-hmm. So what's missing is P3, T3, and V2. And V1.
V1, yeah, you don't really need V1 in essence, but they're making this like, you don't need V1, yeah? Like, you only need the, like, how come
Well,
they said
V1's
here,
actually given on the graph, right? Right here.
if you, let me think about this, because like you started with 2, right?
Mm-hmm. Oh
Like,
yeah,
you
look, it
started,
says V1 equals V3.
but what if you didn't have the graph? It could be like 0.5, you know?
Oh yeah, that's true.
No,
So
I'm
that's
just thinking,
because you would have to give the graph then, right?
but you can't always expect that. You can't be always spoiled,
Then
yeah.
how do we get the values?
That you have to draw out conclusions, like depending on what they give you, you have to draw out a few things and draw it yourself in essence. Like, I mean, if something is unclear, I guess you could ask her.
Mm-hmm.
What I mean is like just be ready, like to not have the
will
graph.
give the graph though. I'm actually gonna email her
Okay, and then
and ask
okay.
if graphs will be given.
Okay, go ahead. Yeah, let's see what she says. It's like,
yeah,
it's probably gonna be another sarcastic answer.
Yeah. Well, because according to your notes, blah 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 blah.
Yeah.
Fucking notes excuse. Please.
Do you know anyone else in that class that shares the same,
What?
And there's like 9 people in that class, right? Like,
Yeah.
do you know anyone else in that class?
Nope.
Okay.
Yeah.
I'm probably thinking like they have the same opinion about her.
Yeah.
And that's why they're not asking questions. Afraid to get, shot down. Okay, let's see.
For problems like problem 8.
For problems like problem 8. Okay, go ahead. It's up to you. Like,
for
like
question or I'm just gonna say problems for problem 8. Whatever.
It's all good. I was just messing. Okay, go ahead. For problems like problem 8.
Problem 8. The initial value, the initial volume was given. The initial pressure and volume was given.
Yeah. Okay.
What else was given from the graph?
The graph tells you like 1, 2. It doesn't really tell you. The thing is, he gives you this relationships in the graph. But it's also in words. I would just ask like, would you? First sentence there is good. I was writing graphs. Yeah, because the thing is, it could be anything. But then that's the main thing. Like, what are the graphs? If they're given, then that's good for me.
Or will it be strictly word problem?
Yeah, where we have to draw the graph. Problem based.
Or will it be strictly word problem based?
Yeah, I think that's good enough.
All right, let's see what she says.
Yeah. Okay, cool. Anyways, where were we at? So like, yeah, you're right. You have this P3, T3 that you need to find, and then other things.
Mm-hmm.
But what it is like, you just it's the same thing as any other thing. What's up?
Oh shit! I found solutions.
How did you get that?
I don't know. Wait, what is this under? Class problem solution.
There you go.
Okay.
What was the other one?
The other one was called today's solution.
But why would you show less in today's one?
I don't know. I really don't know.
Okay.
All
right. Oh, perfect. I don't have to talk. Okay.
For part 1 of the question, this is how your PV diagram should look like. Oh, so she's not going to give it. because
Yeah,
she's getting the graph in the end.
exactly. I mean, I wouldn't like, you know, I mean, it's torture, but it is the concept. It's a concept you need to know, like drawing it. It's not bad. Like I said, like the hardest part here is, you know, the bottom one, the volume relationships. Yeah, that's the hardest part.
So pretty much the answer is just going to be in like terms of like P1, V1, T1.
In this case, yeah. In this case, yeah.
Oh.
It could change in so many different ways.
Eh.
I mean, it's like, I think this is like one of those archetype problems. Like, oh, like draw PV. It's like one of those things. Like I said, like you check it off. Like you get tested on it. It's like one thing you have to get concrete in your mind. Like, can you draw a PV diagram? Can you solve for the pressures and volumes? You know. And then the one thing here is just mastering the like what you can assume, like what this problem does. T1 equals T2. And then you know, ideal gas laws.
Okay, I have a question. So what if it starts off isometric or isochorically? So volume is constant. So it's a straight line.
Straight line, yeah, up to the sky.
And then it becomes isothermally expanded. Is it like a parabola going up or a parabola going down?
So like, wait, hold on. So you start out with isochoric or isometric, whatever.
Which is a straight line.
Okay, and then you want to do isothermal expanded, or yeah, you just go up and you go down, you know, like a curve.
Which curve? Like, how do I orientate it?
Do you have like a pen? Here,
Pen?
I'll show you. Okay, it's like this guy. Hold on, let me just share my thing. Share.
Are you in New York in your photo?
No, it doesn't look like it.
Yeah. Miami?
It's in the other side of New York. What's the other side of New York?
Quebec?
No. It's what do people usually associate like New York to? The what? What's the other city?
Manhattan?
No. Like what's diagonally, you know? Yeah, you have New York, right? But then you go down diagonally, like LA.
Oh, LA. Oh, way on the other side of the fucking nation. Okay.
Exactly.
You're in LA? Oh, wow.
Yeah, LA's pretty nice. But anyways,
you live in California. Duh.
Yeah, right? You can't tell from that. No, like usually we say hello here a lot, so but I don't really say it that much anymore.
Why? Because you grew up?
I'm not really that old from the picture.
How old are you?
28.
Oh, that's not bad.
Yeah.
Yeah,
you're not old.
No, you're not old.
Okay. Let's look at this guy.
Go straight down.
So you know you do this, right? You do this guy, right? So this, and then you go down like this guy, right?
What if it goes down?
No, like if you only go up if it's a compression.
No, I'm saying what if it goes down like isometrically? Is that possible?
I don't understand that. I mean isometric. And you mean
like, okay, this arrow on the line, what if it's like opposite way, like going downwards?
Oh, I see what you're saying. Can it go downwards? Did you guys ever see that? Have you seen that before?
I don't know.
Because like if you think about it, they have to give you this guy.
Like which one's first and which one's second?
Yeah, they have to give you something, you know. And then like the thing is with this, you know, when it says expanded and compression, that usually tells you left to right. You know what I mean?
Yeah, but see, it's hard with the metric because it's a straight line.
Yeah.
It go like expanding or compressing, it goes straight line.
Usually when you're saying like positive, like when it's positive, it's like this guy, up or right. So if there's a problem like that, like going up would be positive and going down would be negative. Does that kind of answer your question? Like, and then, or the other one would be this guy. This is positive meaning like expanded, you know, and then this is negative. This other one is going down, going up.
So like, okay, if it's originally isochoric,
yeah,
then it becomes isothermal.
Okay, what I just drew, yeah, okay.
Right, yeah. So you're starting it from the top point of the isochoric? Why?
So if it tells you like this is expanding, so it depends on like what is it expanding or compressing. Then you start right here if it's expanding. If it's
Or I
compressing,
think it just depends if the pressure is going up or down.
yeah, but then it always depends on like the sign, the sign. You know, like if it's expanding or compressing, that's where you start it. That's where it connects. Same with the other guy. Like this
Okay,
pressure.
wait. So what is it? Okay, so explain that. What is positive and what is negative?
Positive. I just said that one. It's this guy.
No, no, no. I'm saying from like the point after that with the isothermal. If you're gonna do the top point or the bottom point.
So if it's expanding, both of them are expanding. Both of them are expanding. Because
Yeah.
if this is expanding, it's this guy. And then if this is also expanding,
Okay.
it would be that guy, yeah. If it's the other way, you know, if you're compressing, there's always different ways.
Compressing what? The pressure?
Yeah, if you're compressing the isochoric, this guy going down, this is compressive.
But if it's a straight line, isn't it constant?
Not necessarily. It's the same. There's a lot. You're given the shape, but you have to know the direction. You're given the shape.
That's what I don't know. I don't.
You're given these shapes, right? Like you have this guy, isobaric, choric, thermal, right?
Mm-hmm.
But then you have these different points, states. These points are states, and then you need to know whether it's a compressing or expanding. So you know where to go from what to what. If it's compressing,
okay.
in this case, it's going down, and then you start here for the next one. State 1, state 2, and then like maybe this guy is isothermal expanding, so you're going this way. State 3, yeah. You know, like it's kind of like that. That's how you say it. And then the other one, you know, like problem 8, it tells you what it is. It's expanding isothermally, and then it's compressing isobarically.
Mm-hmm. So what if it was expanding isometrically? It would go straight up?
Yeah.
Instead of baric?
This one, for isometric, I really know it as isochoric, but so when you're doing this, like expanding is going up for isometric. And
okay, let's say back to where you were over here on the right side with the isothermal expansion.
Okay.
Okay, erase the baric part.
This one.
Erase that bottom line.
Okay.
We're just at point 2.
What about it?
So what if it says it compresses isochorically. Compresses isochorically that way. Okay.
It's going
and then
down,
if it expands isochorically, it goes up from that point.
You got it. Yeah, you got it. You got it now.
Okay, yeah, that's what I needed to know.
It's not tough, right? Like it's like geometry.
Yeah.
But it's really like like lines and a bunch of concepts. Like how do you draw it? So any of these you can definitely know. You should have asked her the direction. You know, like what does the direction tell you?
Yeah, that's what she didn't give, so I didn't get it.
Because you can't just like, what did she give you guys? Okay, the problem and that's it. There's no explanation.
She just reads the problem and then draws it. She doesn't explain direction. She doesn't explain what the words mean as far as like the picture, nothing. She reads the problem and then draws it.
Yeah, you should definitely like, I don't know. Sometimes when some professors, they don't, so does she not talk while she's like, what is she explaining? Like while she's doing this? You know, like each one of these.
You know, she's not a native English speaker, so that's probably another thing. She's
like but you
Arabic.
Yeah, right. I knew it. But anyways, like you guys, yeah, for her to like, you know, give you a sarcastic answer, maybe it's not so smart to ask her so many different questions. But one thing that she should tell you are the sign conventions, because that's very important with PV.
Yeah.
It's not just drawing it. That's why there's an arrow.
Yeah.
You know, there's 3 main elements. The you know, what are constant between the 2 states? how do you like what is the direction, because it's a vector, like this thing. And then the third thing is like, what are the different assumptions? But with all of that, does it make more sense now, like whatever we just talked about?
Yeah, it makes more sense now.
Okay. What are things like, like that packet of problems, what other things are there besides these two, like ideal gas law and PV?
Okay, that's problem A. Okay. Oh, she only gave up to 8. Great.
Going up to 8?
Yeah.
Okay.
Let me see if there's more though. Or is there only 8? See.
That's a lot already. I mean, if you get all 8, that's good.
Yeah, that's true. Is that where I am?
Yeah, I don't think it's that much. She's not very, like, with all the exams. I guess that's pretty smart to do. To not, because like the very first exam, the very first exam, it was just 2 things in essence. It was just like the stress one, right?
Yeah,
the
it was
stress
the
of fluids.
linear expansion, the Young's modulus, and continuity. That's all she needed.
And then this one is like PV and then and the ideal gas law, which isn't much really. You guys should have like continued. What's after this? What chapter are you guys in after this?
19, but this exam's only over 18. So hold on.
Is it like 1 exam per chapter? Or 1 chapter per exam?
Yeah. She gives an exam after each chapter.
Yeah, I mean that's not bad. That's like super like, you know what I mean? Like that's too easy.
Yeah.
It's like the exams are quizzes in essence.
But that means more exams.
Yeah. Oh yeah, so did you get a good grade in your first exam? Like, what did you find out the actual grade? Out of 100? Oh my goodness. Oh, but you got the extra credit though, right? You got to do more extra credits. I think that will help your grade out, I think.
Yeah.
Okay, so let me know. Let me know for when you guys' next assignment are. I can definitely give you like a solution for that if needed.
Okay, I had a quick question though on this number 1.
Okay, show me that one actually.
Did she give the answer for this one? Fuck, did I exit out of it? God, now I have to find it again.
Number 1. Okay.
Okay, so day's solution or this class problem solution? Let's see. See, okay, why did she do that? She like cuts them in half.
What is that? The slides or
like, the number the solution? Yeah. There we go. Okay. All right, right here.
I can't see it.
oh, sorry, I didn't share my screen.
Yeah, no worries.
There we go. Okay. Boom, right here.
Okay. All right, let me breeze. What is the gas pressure? Okay. Okay. Ideal gas.
So I get it all because it gives all of the values except for P, right?
Yeah, we talked about this one. For ideal gas law, usually if they're not like your professor, they usually give it all to all the different ones, and then the only unknown here is pressure, which makes sense, right?
Right. So this is what I don't get though. In the end,
what is it?
Why is there 32? N equals 100 divided by 32. Where's the 32 from?
I see. Oxygen, gas. Oh, that was an easy one, right?
So it's like, what is it on the periodic table? Let me see.
Do you remember this one? This is chemistry.
I hate chemistry. Well, no, I kind of like it more than this. That's for sure. But I don't remember all the details of all the elements. Hell no.
No one memorizes periodic table, so it's there. Okay. I think that right there tells you it's 16. Do you remember what 16 or 15.999 stands for?
Atomic something.
Yeah, it's atomic mass, I think. Yeah.
Okay.
Or atomic weight.
Mass times
whatever.
2?
Yeah, you know why?
No.
Because you know how it's inert, right?
It's what?
Inert. Do you remember that word? I'm just throwing this what the?
What? What is that? I don't even know what that means.
No, because it can't. Oxygen is inert, so it can't be one atom. It has to be 2. Whatever. That's what it means. But
Oh.
it's an oxygen gas, so it has to be O2. It can't be O1.
Okay, so what if she throws a random element at me? How am I supposed to know? If it's
Yeah. Oh, yeah. That would suck because it's in person. And you don't have your computer in front of you.
or a
Yeah.
periodic table or anything.
I think she won't be that harsh. No, that's another question. That would be another question. Do we need a periodic table, or will you give us atomic masses?
Yeah, because
But you got that equation, the mole equation, right? N equals 100, because that's like I call it the molecular weight. So you divide it by molecular weight, but you're given the mass, I think, right? Yeah, mass over molecular weight is the moles.
yeah, hold on. Yeah, because she said you're always gonna use moles when you're given mass.
Exactly.
So
Yeah.
she gave mass, which is 100 grams.
They always give you mass. That's the other thing I forgot to tell you, but they'll always want to give you mass because you always want to convert it after, given all these different things and be like, oh, I don't want to use mass. There is a mass version of the ideal gas law, but no one ever uses it. You always want to convert everything to the moles or N.
Mm-hmm.
And then I guess if you were given the periodic table, I guess just remember oxygen is pretty common, like that's 16 times 2, so that's pretty common, right?
Mm-hmm.
And what other ones? Maybe nitrogen gas, N2, H2, hydrogen gas.
So nitrogen and hydrogen have 2, so you would have to multiply those atomic masses by 2 as well.
Yepers, yep. It's that concept. They'll never tell you, like, oh shoot, why is it, unless they give you the chemical compound, unless they give that
I
to you.
think she should do that if she's gonna do that. And if it's on the exam and it's not there, I'm gonna ask her for it. Because I'm gonna be like, honestly, you didn't tell us to study the details of these elements, so I don't think that's fair.
It's not fair, yeah. But like a lot of times they will give you either one. But like if it's in words like this, but like I said, like hydrogen, nitrogen, oxygen, just remember those ones. You remember H though, right? Like H is 1. That one's like simple.
Okay, so H is 1, N is 2, and O is 2.
And no, like not 1, like the molecular weight. The molecular weight.
Oh, the molecular weight. Okay.
Yeah. Because it's the first one, right?
Yeah, that's true. Yeah. Okay.
And what about nitrogen? What is the molecular weight of nitrogen?
I don't know. Let's see.
Those 3 are pretty common. 1, 14, and 16.
14?
Yeah, 1, 14, and 16.
Molecular weight?
Yeah. Can you bring anything, or is it like closed notes?
Closed notes, bro.
It's like this. Usually physics isn't like that.
I know, right?
Usually math is like that. Like, like math is the one where you memorize things. Physics and like, related classes are usually open notes.
She's letting us bring a calculator, but that's
But then again, it's only 1 chapter. Maybe that's why.
Yeah.
You're only getting tested 1 chapter. This is like high school. It's college. Like what? 1 chapter? Are you serious? No, I'm just kidding.
True.
So that's probably why it's like closed notes.
Yeah.
Okay. So that one you get. That one you get now. Okay.
That I get. I need to practice converting meters and centimeters and all that because I still have to look it up.
Oh yeah, for that one, yeah. That one is just a conversion. It's another thing you have to remember, yeah.
Yeah.
And this one you.
2.
How much is the increase in gas? Okay. This one's not bad. Increase, delta P, yeah. Yep.
Oh yeah. So I was doing this one. This is another one that I practiced, and I got it up until the P1 over P2. Oh yeah. So from this.
Yeah. Okay.
This P1 over T1 equals P2.
So do you get the volume in V1 equals V2 and N1 equals N2? Do you get those two?
Yes.
Okay.
Yeah, because volume is constant
It's
And
sealed,
it's a
yeah.
sealed container, so N is constant, so you don't have to consider either one of those. They cancel.
Cool. Yep, yeah.
Right.
What
Yeah,
was
I get
the
that.
question though? Like, what was your
My
question?
question is, how did she manipulate the equation to go from this highlighted part to P1 over P2 equal like this part? Like,
Because V2 to that guy or to that guy? That one is easy. From P1, you just swap the P2s, right? Or let me see what's happening here. P1 over T2, T1, okay. And then yeah, you just swap the T1 and P2, right?
oh wait, no, yeah, I get that. I get that. But
Yeah, okay. I don't like how like why is it written this way? I hate it when
I
it's
don't
like
know,
written
it's confusing.
horizontally. Why isn't this written horizontally or
I
vertically?
know.
I,
Seriously.
it's because it's being written. That's why she's probably like going to the whiteboard or something. I don't know. Okay, so you get that one. So, what about this other one? The P.
Oh, this is what I. Wait, okay.
Okay.
Equals 1. Oh, okay. This is what I don't get. The change in P. So I know change in P is P2 minus P1.
Yeah.
But then it equals 1 over 0.79 P1 minus P1. What?
See, this is when you do when you do horizontal typing, this is what happens. Okay, 1 over 0.779. Where is that coming from? It's this thing, the 0.789. I think that's what that is. 0.789.
Oh no,
And,
yeah, I know that. I know this.
Yeah,
that's the fraction there. I know that because it's from all this work that we just did. But what I don't get,
it's P2, right? That's P2. That's what I'm saying. That's P2, right? Isn't it P2? That 1 over
no,
0.7.
that value, this value is P1 over P2. This is P1 over P2.
Yeah, P1 over P2. What's a little bit confusing is let me think. Is P1 being times as a numerator or denominator? Which one is it?
Yeah, see, that's what I don't know.
Because then P1 over P2, that's like the ratio, and you times it by P1, which is what's given to you, right? It's given to you.
Mm-hmm.
Or is it given to you? It's not given to you. But it's a variable. Let me just think about this first. P1 over P2, okay. Oh, it's being multiplied by at the bottom.
Is it?
Yeah, because like, P2 to cancel out the P1 up top. To cancel out the P1 up top. So that cancels out, you get P2.
What?
Like what the heck? Let me expand that one. Let me just see.
Yeah,
Let me
like
check.
just this part, the change in P part. This just needs to be rewritten because.
Minus, what is that? -1? Yeah. She minuses 1 from it, you get 22. So, because it is right, but that ratio right there is whatever gives you P2. It's pretty much 1 over 0.79 because it's P2.
Wait, are you writing it?
No, I'm not writing anything. I'm just talking.
Oh, okay.
You see this P1 over P2, right? The P1 over P2.
P1 over P2 is 0.789, right? Or 0.79. I know that.
And how do you get P2 over P1 from that?
P2 over P1?
Yeah. You have to do the inverse, right?
Oh, the inverse, which is 1/0 or
reciprocal, not the inverse. It's just a reciprocal.
Oh, okay. So P2 over P1 is 1 over 0.79, right?
Yeah. But do you get it though? Like, because P2 needs to pop out, so you have to do 1 over 0.79, which is P2, and then you times it by P1 to cancel out the P1 from the ratio.
What?
To cancel out the P1 from the ratio. I get it. Here, let me share my screen.
Okay.
It's not that bad. It's just a mathematical construct. It's when you take a look at that guy, right? when you take a look at, so you have 1 over 0.79,
Yeah.
and then P1 over P2 was what? 0.79.
0.79, yeah.
Yeah. So what is P2 over P1? 1 over
1 over
0.79.
Yeah.
Yeah.
Uh-huh.
And then you want to get P2, right?
Yeah.
So it's a P2 over P1 times P1 gives you P2, right?
Wait, so we multiply P1 on this side, right? To cancel it out times P1. So P2 is P1 over 0.79, right?
Yeah. So, but do you get this part right here? This, the one I circled? Like where you cancel out P1, you get P2?
Yes. Yeah, that's what I just did. So now P2 is equal to P1 over 0.79.
Yeah. So it's pretty much this guy. And then you just plug this in. You just plug in what you know from here, which is P1, right? 1 over 0.79 times P1.
Oh, I see now. Oh, so this was all P2 all along.
Yeah.
Minus
It's not that bad.
Okay, she just skipped a whole
But
lot of algebra.
like I said, like, you know how the same way as how I usually write like my Mathematica, like you'll never see the steps unless she writes it down the same way as I would write it down.
Yeah, I get it now.
Yeah, but the thing is, like her writing and the way she explains is not that fair as well compared to the way she writes it or she types it.
Yeah, she should just stick to writing it down and not typing it.
Yeah. Did she ask for you guys' feedback? But probably not. No.
No, I'm definitely gonna leave that as a remark.
No, but like she's not new though, right? She's not new.
I have no idea. I think she is new.
Oh.
I mean, she doesn't seem like new to teaching, but she seems new to like UTEP and like the United States.
I knew you were gonna say that. Okay.
Yeah.
Well, but then again, just for the most part, it's not that bad. As I've known, like my Arabic teachers, they're lenient. You know, is what I'm saying. Like in grading. But yeah, like I guess for this exam, for tomorrow, do you feel confident now or?
Yeah, a little more confident.
Okay, good. So I'm hoping you get an A because you got what was it? Almost that's not bad.
Almost a B. I got a C.
Yeah, I know. That's pretty bad.
Yeah. At least I passed though. I don't care. I just don't want to take this class.
No, you need to get an A. Nah, because this class isn't that bad.
I doubt I'm gonna get an A. A B if I'm blessed.
Yeah. Nah, this one, like I would say, take this one. This chapter is super easy. Yeah. You can definitely make it up. Like you can get 100 and still get like a B in the class, if anything. Okay.
Yeah.
I think that's I think it's 7. Yeah. So for the next one, do you want to just give me the next couple chapter homeworks, and then we can do another. I think the next one is harder than chapter 18. Definitely, it's thermodynamics. I think. Nah, you'll survive.
I really don't know.
Yeah, let me know if the exam was hard or easy. I'm gonna think that it's not that bad if you did like problems 1 to 8.
Yeah, I'm hoping that the exam is just problems 1 to 8.
Yeah, but like if you see the correlation, if there is one, right now, it seems like she focuses more on the easy problems, right?
Yeah.
Like from problem 1, exam 1.
Mm-hmm.
Yeah. So I would probably focus more, if that's the case, focus more on like the ideal gas law, not the PV diagrams.
Okay.
Yeah. Cool.
All right. Well, that was
Alrighty.
good. Thank you.
Yep. Yeah.
I'll let you know how the exam goes, and I'll send you the homework when I get it.
Okay. Yeah, and then like the time for next week, just let me know. I know it's been like floating, like it's either it went from Sunday to like whatever day.
So Wednesday to Tuesday.
No, I'm sure I've been getting a lot of clients now, so it's pretty good. Like doing more like physics. physics 2, physics 1, calculus, all of that. So
Oof, God.
yeah.
Oh,
No, it's
torture.
always fun. I don't know, but it's always fun to like look back into these subjects and it's like, oh man, it was so hard, and now like I'm teaching it.
Yeah,
No, it's all
because
good.
you really learn something once you teach it. Like that's the best way to learn is by,
It-
or like memorizing something is by teaching it.
yeah, I don't know. I think it's good. Like it's some. It depends on like if you like, because you need to have a lot of patience, you know.
Yeah.
Yeah, but I like doing it because I'm just giving back to. Yeah, I always thought myself like, okay, besides like doing your day-to-day work, like which you will eventually, uh, the I going back to academia, I was like, oh, do you want to do this? Do you want to do that? I always feel like learning the basics and teaching the next generation is like worthwhile than just like doing it for yourself. You know what I mean?
Yeah, that's true.
Yeah. Okay. Cool. All
All
right. See
right.
you next week. Cool.
All
Bye.
right. See you. Have a nice week. Bye.
Yep.